In this video, we'll discuss some of the basic fraction properties. So we're starting out with some very basic properties here. First of all, fractions with a denominator of 1. If we take any integer and put it above 1, then we get something very simple. It just equals that integer. So 7 over 1 equals 7, or 135 over 1 equals 135. In general, the pattern is n over 1 equals n. Now, it's very important to appreciate that, first of all, we can use this to write an integer as a fraction. So if we had 4, we could write 4 as a fraction. We could write it as 4 over 1. We could write any integer n as the fraction n over 1. Well, why is this important? This is not tested directly. The test is not going to ask you, what does 135 over 1 equal? That's not going to be a question. But this is an important step in problem solving. For example, later on, when we talk about adding fractions, we talk about how to add a fraction to a number, to a whole number. Well, it turns out that it's very useful in that scenario to rewrite the whole number as a fraction. And this is how we'll write any integer as a fraction, just by putting it over 1. So 4 we can write as a fraction, writing it as 4 over 1. That's an important problem-solving step that we'll need later. Second property, fractions involving 0. This is a tricky issue. People sometimes get confused here. So let's be clear. First of all, we cannot divide by 0 ever. It breaks the mathematical law to divide by 0. So in other words, to have a fraction with 0 in the denominator, that actually breaks the mathematical law. That creates something that goes outside the realm where we're able to assign mathematical meaning. So it is, in the most profound sense, something mathematically meaningless. So the test is not going to make you deal with things that are mathematically meaningless. So don't worry. You're not going to be asked to evaluate a fraction with 0 in the denominator. You just have to remember that is an illegal thing. That is something you have to keep an eye out for. If that's a possibility, things no longer make sense. Now, having said all that, it's perfectly allowable to divide 0 by a number. We can have 0 in a numerator. That's perfectly fine. 0 divided by 5 is 0. 0 divided by negative 3 equals 0. Those are 100% valid equations. We can write the equal sign. That is well within the realm of mathematics there. 0 divided by any non-zero number equals 0. Very important. 0 can never be in the denominator, but is perfectly fine in the numerator. Fractions of the form n over n. So what's going on here? As long as n is not equal to 0, then n over n equals 1. So here n could be an integer, but it could be any other kind of number. It could be positive, it could be negative, it could be a decimal, it could be an ugly radical. It could be any kind of thing. As long as we put anything over itself, as long as it doesn't equal 0, then anything over itself equals 1. The big idea here is we can always multiply any expression by n over n, because multiplying by 1 never changes the value of anything. And this will be hugely important when we get to the point where we have to find common denominators. So this is a really important fundamental idea, and we'll return to this later. Finally, the issue of reciprocals. This is actually a word you need to know. The test could use the word reciprocal in a problem, so you need to recognize this word. The reciprocal of a fraction, a over b, is the flipped over fraction b over a. Again, we're assuming that both a and b are unequal to 0. So for example, the reciprocal of 3/5 is 5/3. The reciprocal of negative 7/2 is negative 2/7. The reciprocal of 1/6 is 6 over 1. Well, 6 over 1, as we saw a moment ago, just equals 6. It equals the integer 6. So the reciprocal of 1/6, the fraction 1/6, is the integer 6. So there are a few important properties of reciprocals that it's important to know. First of all, the product of any fraction with its reciprocal equals 1. So they cancel out. So 4 17ths times 17 over 4 equals 1. That's a really important idea, and we're going to use this to solve a problem in a few minutes. Second, the reciprocal of any positive integer is simply 1 divided by that integer. So the reciprocal of 6 is 1/6. The reciprocal of 117 is 1 over 117. In general, the pattern is the reciprocal of n is 1 over n. Now, certainly this works when n is an integer, but it turns out n doesn't even have to be an integer. We can extend the pattern, and we can use that same pattern when n is not an integer. So 1 divided by any number, for example, 1 divided by a fraction equals the reciprocal of that fraction. So if I take 1 divided by 3/7, that's going to equal the reciprocal of 3/7, which is 7/3. So that's a really deep idea there. This already suggests the rule for fraction division, which we'll discuss in an upcoming video. So if you really understand this connection well, you will understand fraction division well. Finally, if a number is bigger than 1, then its reciprocal is smaller, between 0 and 1. If a number is between 0 and 1, then its reciprocal is larger than 1. It's very important to have this fundamental number sense, that how big a number is, how big its reciprocal is going to be. Very important to have a keen sense of how big and small numbers are. So here's a practice problem. I'll recommend pause the video here, and then we'll talk about this problem. Okay, the reciprocal of a positive number times the cube of the same number equals 5. What is the number? Well, I'm going to represent this unknown number by x. I'm going to use a little algebra here. So if x is the number, the reciprocal is 1 over x. And of course, the cube is x cubed. So we're saying that 1 over x times x cubed equals 5. That's our fundamental equation. Well, that x cubed, literally that means x times x times x. I'm just going to write that out. Now I'm going to take advantage of the first property of reciprocals, namely, a number times its reciprocal cancels out. A number times its reciprocal is 1. So 1 over x times x, together that's just going to equal 1. So they cancel, and I'm just left with x times x. So in other words, 5 equals x squared. Now, normally we'd have to consider both the positive and the negative square root, but the problem tells us that we're dealing with a positive number. So because we're given that guarantee, we only have to consider the positive root, and that means that x equals positive square root of 5. In summary, any fraction of the form n over 1 equals n. So in particular, this allows us to write any integer as a fraction, and that turns out to be useful in a variety of circumstances. Fractions with 0, we talked about these. So 0 can be in the numerator, 0 divided by n is 0, but 0 can never be in the denominator of a fraction. That's very important. We talked about the rule n over n equals 1, and again, how this will be very important as a multiplier. We can always multiply by n over n, because when we're multiplying by that, we're multiplying by 1. And finally, we talked about the properties of reciprocals.